This is what we said. I'm reminding you. I'm not asking you to solve it. This is what we did. Remember that cis, and then we are asking strong base. Because of strong base, this is E2. And then the hydrogen and adjacent carbon can be taken by the base. Question?
Could you go back, show the major? Oh, okay. Thank you.
Would the non-rearranged neonickel also react to create
Yes.
elimination?
What I didn't show here, this question says elimination product. If I didn't say give me the products, then you should also consider substitution product. Substitution can happen with this, substitution can happen with that. But between these two, I think these will be more stable carbocation. The substitution product with that will make the forms of substitution product compared to the other one. Sure. All right, so this one, let me remind you what we just talked about, because things can happen. I mean, we can change the question, we change the structures, but we can change also other things to make it difficult. So this is what I just showed you. You have a cis molecule, bromine is there, but there's adjacent hydrogen. We are only looking for the trans hydrogen because that is makes the identical twin possible for the E2. And then if you base couple come pick up this one, you get the double bond on the less substituted side. If you more hydrogen on the more substituted side goes, then you get the more substituted double bond. We already talked about that's a major product, right? It's basically what we did. You've seen it before. That same molecule, I just turn it up upside down. The same molecule. We got the cis, same molecule there. What I changed it in, I changed the reagent. It's a dark side. I mean, not a dark side, it's ethanol, conjugate acid forms of that. But it can act in the base, not a strong one. What would be the elimination product? Should it be the same as this? Because that was the answer for this one. We asked elimination product with this, you got that as an answer. We asked elimination products with the same thing, then it should be the same answer, isn't it? But I'm trying to tell you that, same message, you cannot memorize these things. I'm going to show you how things change if you react differently. This is the ethanol, not a dark side. This is not a strong base, right? It's not a strong base. So can E2 elimination reaction happen with this? No, there's no way. These things are not strong. And then we have a silicon nitrate, which means that we are basically make a formation of the carbocation goes better. So this is actually the E1 mechanisms. So what we're going to see is that this base can't pick up the proton, make a double bond, forms, bromine goes out, make the same E2 product. That is not going to happen because these things are not strong. You cannot expect that with these reagents. So only thing can possibly happen, bromine goes out, make a carbocation, because nothing else is happening. Your base is not doing its job because it's too big. So only thing can happen, this molecule, waiting until the carbocation forms. Takes time, but once it forms, then things can happen. That now you need to think about, as soon as you use the carbocation, what I asked you to think about. Possibility of the rearrangement. So will it rearrange? Is there more substituted position in the next orbit? Right? This is a secondary carbocation. It's not going to move on that the other side because the that makes a secondary carbocation. But on that side, more substituted side, we have a hydrogen. So if the hydrogen moves, then we get a more substituted carbocation. So rearrangement will happen. And now this carbocation will go through SN1 and E1, but we're not talking about SN1 because the questions are only asking elimination. Elimination, we need to think about the same thing, adjacent hydrogen. There's an adjacent hydrogen on that side, adjacent hydrogen from this one, there's another one, but this one is the same as that one. Right? So when the solvent comes pick up the hydrogen, you're going to have a double bonds here. That's E1 products. If the solvent comes pick up that hydrogen, then you're going to have double bonds over here, which makes that one. So which one of those two with the major products. That one, right? Which is actually same as the other one. So actually, but even though you probably didn't know it goes to different mechanism, if you just guess that, oh, I've seen that as a major product, and then I just put it there, and somehow you got the right answer, even though you process it. So that's possible. I'm not saying that it's not impossible. It's not always right, that's what I'm trying to say. So this one happens to be the same product, regardless what reagent you use. Strong base you use, you get that as a major. Weak base you use, you get that as a major. The same product, both cases. Change the question to the trends. Now we see the trends. I'm reminding you, trends, you see here, these hydrogens are not being taken out because there's a cis to the bromine. No anticoplanar you can achieve with the hydrogen on the same side, right? So that's the reason you get only this as a major product if you use it strong base, and then things going to the E to eliminator reaction. What about same trends with the same condition that we had before? Now you know this is ethanol. That is not a strong base, so we're not expecting that weak base pulling it out the hydrogen and then make a double bond formation. That is not going to happen. I mean, if besides, this is not the right hydrogen because there's not anticoplanar possible with it. Even ethanol picking up that hydrogen, that is not possible because it's not going to happen by the E2 mechanism, right? Weak base doesn't do the E2. Only thing it does, it has to wait it out until the bromine goes out, you get the carbocation forms. That's the only thing that is happening. When the carbocation forms, then what I ask you to remember, the arrangement, right? I mean, you've been hearing me say same thing over and over again. I hope that it's right in your memory. But that is going to see the possibility of rearrangement, not to the other side, to this side, because that makes a more substituted carbocation. So that happens. This will go through the E1 reaction, as we just talked about. There are two different adjacent hydrogen, less substituted one, more substituted one. But the less substituted one will make a more less substituted double bonds. More substituted carbon will make a more substituted double bonds. Between these two, which was a major product, we just did it in the last slide. So this is a major product. And obviously, that hydrogen can be also taken out from that, but this is a minor carbocation compared to this one. That's a more stable one. That's still going to be the major. So these molecular trends, depending on what reagent you use, you get different answer. If you're using a strong base, you get this as a right answer. If you're using a weak base, that is the right answer. So answer changes depending on what you use as a reagent.